Hello, I am a Cosmin Man, and in this video I will show you how to use publicly available datasets to extract useful information about the land resources. The goal is to learn how to use some forest inventory data, in this case the BC Vegetation Resource Inventory or VRI, and assess the existing conditions for an area of interest. For this example, I will use the VRI clip to Bulkley TSA located near Smithers, British Columbia. The VRI is a geographical dataset that can be mapped in GIS applications such as ArcMap, and it comes with an attribute table that includes a range of fields or columns that can be used to extract information about the land. Using this table, useful information can be summarized for the area of interest. Such information includes area distribution over land types, standing volume, and age classes. There are 6 steps that one needs to take in order to extract such information. In the first step, one needs to organize the data obtained from public sources. In this video, I use the VRI and TSA datasets accessed from DataBC website. To access the data, go to your web browser and search for DataBC. Go to the DataBC website, and in the search box here, just type in the dataset you are looking for. In this case, it is VRI, so I simply type in VRI, hit enter, and the first search result is what I need. I just click again on it, and I see here my options for accessing the dataset. To download, simply click on the link, and the download will start automatically. However, not all datasets can be accessed directly as was the case of the VRI. For example, if I'm looking for the TSA dataset, the other dataset that I use for this video, I find something like this, which might be useful. However, this particular dataset is only available for government, so you can view it publicly, but it can only be downloaded by the government. However, there is a dataset in this case for the TSA that can be accessed publicly, so simply copy the name here and search this TSA name, and I find another one that doesn't have SPG at the end. So if I click on this one, it can be downloaded publicly. To download it, you would simply have to click on this custom download link and type in your email address, select the dataset type you want. In this case, I prefer the file geodatabase. Type in your email address, accept the terms and conditions, and submit order. To organize the datasets, I use Arc Catalog. To access Arc Catalog in Windows 7, simply go to the Start menu, All Programs, and ArcGIS, and the Arc Catalog is located there. I already opened it up, and you would have to browse to your data sets and you can look at them, you can preview them, and you can copy and move them between file geodatabases. However, if this is the first time when you're using our catalog, you would need to connect to a folder so you are able to see your data sets. To do that, you would go to this button which says connect to folder. You would click on it and select the entire drive. In my case, is data E drive. For the purpose of this video, I use this Bulkley VRI clip dataset located in the file geodatabase called class examples. And the way I got this dataset was by clipping the VRI to the Bulkley TSA. However, I don't like where this dataset is located, and I want to move it in a new file geodatabase. I'm going to create a new file geodatabase in this folder where I want it to be by simply right-clicking in this white field, select New and File Geodatabase. I'll rename this to Bulkley TSA with VRI. Hit Enter, and now I'm going to copy the data set that I'm interested in that file geodatabase. To do this, you would simply select the database you want to copy, right-click, copy, go to the database you want to copy to, right-click, paste. Click OK, and this will transfer the dataset. Here I can preview my dataset as a geography or as a table. The second step is to transfer this table into a text file and be able to link it to a Microsoft Access database. To transfer it to a text file, you simply preview the dataset in table mode and go to the table options button. Click on it and then select export. Browse to the location where you want to export your table. Make sure you select the type as text file and give it a name. I'll give it bulkly tsa_vri.text and click save, and then OK. Now that the transfer is complete, I can simply close the R catalog and access my exported text file using Windows Explorer. So if I go to my folder, I can see here the bulk tsa_vri text exported already. The third step is to link the text file to a Microsoft Access database. I don't have an Access database yet, so I'm going to create a new one in this folder. To do this, just right-click, select New, Microsoft Access database, and give it a name. Let's call it bulkly TSA. And double-click on it to open the Access database. Make sure you click on this Enable Content button to avoid other security warnings. And now let's link the text file to this database. To do this, I go to the External Data menu, select Text File, and browse to the location where my text file is. Select it, click Open, then select Link the data source by creating a linked table. The first option imports the entire table. Click OK. Delimited is the right options in this case. Click Next. There are two things you need to do here. First, the text qualifier needs to be code sign, and then you select first row contains field names. Comma as the delimiter that separates field is the right option. Click Next. Next, and finish. And I receive a message saying that the text file has been successfully linked to my database. Click OK. The fourth step is to develop queries to summarize the data. The first query I'm going to develop will calculate the entire area of the TSA. To create any query, go into the menu Create, select Query Design, and select the table you want to add, or queries, or both, to your query. In this case, I only want to add a table, so I select the table and click Add, and then Close. I can readjust this table view here to see all the fields that are included in my table. You see there are quite a few. Now to calculate the area of my entire TSA, I will select the shape area field, drag it into the field column here, make sure the totals button is selected, and from the total row select sum. Note that the shape area that comes from a file geodatabase feature dataset, it is in square meters. However, this is less meaningful for a forest planner. Meaningful metric is hectares for area. So I need to report this area in hectares. To do this, I simply select shape area here and type in divide by 10,000 and then hit enter. Access automatically creates an expression and labels it expression 1. This label here goes into the field name in the query result. So I can edit this and call it area underscore hectares. So I know this field will report area in hectares, not square meters. Once I'm done, I just click View to view the result. And here it is. However, as you can see, the number is difficult to read, it's not in a standard format. So I go back to the Edit view, and in the Property sheet for the field selected, I click Format and select the standard. So now if I click to view the results, the area is shown in a standard format so I can read it better. To save the query, simply right click on the query name here and select Save and give it a name. The name for this query would be 01 underscore area underscore total. Putting numbers in front of your queries gives you an easier way to organize yourself with the many queries we're going to create. The second query I'm going to create will show me the area distribution over land types. To do this, again, go into the menu Create, Query Design, add the table, close, readjust the table here, and scroll down to the BC LCS levels 1 to 5. So these fields indicate the land types available on my DSA. To figure out what values are in these fields and what they mean, you need to access the data dictionary for the VRI. To do this, you would open your internet browser and search VRI data dictionary. Go to the results and you can download this data dictionary in a PDF format. The data dictionary looks like this, and it lists all the fields in your VRI table and explains what they are. So in this case, I'm interested in finding what BCLCS is. So by hitting Ctrl F, I open the Find window and type in BCLCS. And I found BCLCS level 1. It describes what the field means and what possible values it has. So it has V, N, and U, and what they mean. Similarly, you can go and look for other levels. For this exercise, however, I only need the first 3 levels to indicate what kind of land types I have in there. So I simply select those 3, drag them into the table here, make sure I have total selected, and I need shape area for each of these categories. I drag that in, select sum for the shape area, make sure I report this in hectares, so I divide it by 10,000 and edit the expression label to area underscore hectares and hit enter. However, I need to change the property sheet here because it's a number, so I go and change the format to standard and then click view to view the results. So here they are. It gives me for each unique combination for a BC LCS level 1, 2, 3, what is the area. To check if that matched the previous total area number that I've got, simply click on totals here and select sum from the pull down menu. So it's the same number. Again, I'm going to save this query as 02 underscore area underscore BC LCS overview and click OK. The next set of queries will have to be developed in such a way so I can fill in these numbers here. So for example, I'm interested how much area is forested, how much of that non-forested area is alpine or is not typed, or is a wetland, or is simply open land, or doesn't have any trees growing on it. And I also have to determine for the forested area how much is natural, how much is managed, meaning that it has some harvested activities in the past, and by leading species, by productivity or by site index categories, and by back. The first step here is to figure out how much area is forested. To do that, I'm going to create a query that will give me just that. So I'm going back to my Access database, and create a new query. And try to figure out how much of that area is forested. So I know that the BCLCS level 1 to 3 is what I need. Make sure the totals button is selected and is grouped by, and under criteria line I'm going to type in the level that I'm looking for. So if I'm looking at the data dictionary again, I can figure out that I need, for level 1 of the BC land class classification, I need V. Level 2, I need T, being that it's vegetated with trees on it. And for level 3, I will need upland. So VTU. So I'll type in for level 1 V, level 2 T, and level 3 U. The next field I'm going to include here is the leading species, to see how my forested area is distributed by the leading species. To do this, I go into my table fields and select species CD1, and then make sure I drag in the shaper as well, divided by 10,000, change expression 1 to area underscore hectares, and instead of group by I need the sum. Also make sure the format of this field will be standard, and click view to view the result of this query. So you can see here that some of data, even if it's VTU, has no leading species, therefore is non-forested. So I call this area not type, meaning that has no species on it. Save this query again, right click on it, save, and call it 03 underscore area forested by species, and click OK. The next query I'm going to create will determine the forested area that is natural, meaning that has no harvest history on it. So again, go to menu create, select query design, add the table in there, adjust a little bit the view of the fields. I need again the BC land classes levels 1 to 3, same criteria VTU. Make sure the totals button is selected. Now the next step is I need to determine how much of this area actually has species on. So I'll scroll down to the species CD field, drag it in here, and make sure this one is not null, meaning that has records in it. And the other one that I'm interested in is if this particular polygon has some harvest history on it. So I'll just go here in the fields column and look for the field called harvest date. A quick way of looking is to just select one of the fields and click H, so it goes to the next field that starts with the letter H. So I already have it, harvest date. Drag it in here and make sure this one is null, meaning that there is no harvest date in there. So again, to see the description of this field, just go into the VRI data dictionary and look for harvest underscore date, for example. So once I created this, I need the area for all the records that meet these criteria. So drag in shape area again, make sure you report this in hectares, so divide it by 10,000 and select sum, rename expression 1 to area underscore hectares, and make sure the format is also a standard format. Now that I have all this in here and I want to view how the query looks like, it will give me a pretty long table by each species and all of these codes. However, I want to really just a value for this forested area. I don't need to know what it's under each of these. So I can deselect for species and harvest date. I don't want this to be shown. in my query result. And also instead of group, I'll select here where, meaning that I want you to show me in this query the sum of area for all the records that have a species ID in there. So where species ID is not null and where harvest date is null. And now click on view to view the results. So I only have one line, which is all I needed. Again, to save the query, right click on it, click save, give it a name 04 area underscore forested underscore natural, meaning these are all natural stamps with no harvest history on them. The next query I'm going to create is pretty much the same as this one. However, the only change I have to make is harvest date from being null to not being null. So to avoid all these steps to go here and create a new query and add all those fields, I'll simply copy this query. So right click on here, click copy, right click, click paste, and rename it to 05 area forested managed, and click OK. Now I have 05 query here, select it, right click on it and click design view, and it brings me the window of the design view. So all I need to change again here, this field harvested from being null to is not null, and click view to see the results of the query. So far I created enough queries to be able to determine and fill in these fields here. However, I need to create queries again to show me the forested area by productivity, which is the site index in this particular case, and by back. So to do that, I'll go again to my Access database, copy the last query and paste it here, and rename it to 06 area forested by SI from site index. Click OK. Again, right click on it, design view, and I need here, instead of harvest date, and just look for the site index field in my field table. So again, select one of the fields and press letter S to go to the site index. Site index, here it is. I'll just drag it in here, and this should stay the same. I want this to show these values to me for all forested area by site index. Click view to see the results of the query. So it shows me for all those combinations for every site index value that it finds. However, I don't like where it is located, so I just select the column and drag it before the area, so I can see site index first and then area will be the last column in the query result. Click view again to see the results of the query, so it looks much better now. The last query that I'm going to create is the one that will show me the forested area by geoclimatic ecosystem classification. To do this, I go again to my database, create a new query. However, because this new query is similar to the previous one, I just copy and paste the previous one. So right click, copy, right click, paste, rename it to 07 area forested by back, and click OK. Now right click on the query, design view, and instead of site index I need back. So I can either go in here and from the pull down menu look for back. It should be back zone code, or I can simply look it in here and drag it in the next available column here. Now let's see the results for the back zone code, and yes, this is what I need. You can go back to the design view, save, and you can close the query. The next step is to transfer all these query results into an Excel file and be able to build a nice table as this one, for example, here. So to do this, I created this Excel file and added a new spreadsheet called queries area. And because I'm organized, I always put the source and the query series that this particular data set has been developed from. So first I need total area. So I go into my access. I can simply double click on the area total query and to see the result. And if I click on this triangle button here, it selects everything in the query results, and hit Ctrl C from copy and go into my Excel, the location where I want to paste it, and hit Ctrl V, and it pastes the results there. You can do the same for all the other queries we ran, which I already did, and I pasted the values in here. One last query that I didn't show how to do is the forested area by age. So that query is pretty simple to build. It's very similar to the area forested by back. So I just copy this query and paste it and rename it. And I'll make it 08 area forested by age. Click OK. And right click design view, and instead of back zone code I need the age. So the age field in the VRI dataset is called proj age 1 or proj age 2. 1 refers to the dominant layer, 2 to the co-dominant layer. So typically you go by project age 1 and click view, and it will give me the area by age, project age 1, so I can build that nice graph, age plus distribution by area. To populate this summary table, simply link these cells to the corresponding cells in this query's results, and everything should fall into place. For example, if I want the forested area, so if I want this forested area, it is the sum, as you can see, sum in queries area E10 to E27. So this is E10 to E27. So this is the sum of the forested area. Or it can be the sum of these two, like natural or managed. Or it can be the sum of this. The rest is non-forested area, which is split by non-type species. And this is the actual area that has no species on it, so it's this area here. And then the other categories like alpine, wetland, exposed land, and non-treed, which can be pulled off from this results query in here. Similarly to the area queries, you can create queries to summarize the volume for your area interest, not just the actual area. And to do this, all the queries are similar to what we just created, but instead of using the shape area, you would have to use one of the fields that refer to the volumes. And look at all these fields here towards the end of your table that refer to the volume. So you have live volume per hectare for each of the 6 species on that volume. For 3 merge criteria, which refer to the dBH in centimeters. It can be 12.5, 17.5, or 22.5. So you have volume per hectare for individual species, live on that, and total for each of the polygons or each of the records. So live stand volume 125, 175, 225, and so on. For example, I need total volume for the forested area. Because these queries are similar, I'll just copy the last one and paste it in and rename it. So I'll just copy and paste, rename it to, I'm changing the series number here, so instead of zeros I'm going to series 10. So I'll say 10, and instead of area I'll say volume forested total. So I want to know the initial condition of the forest, how much volume is standing on my area. So again, right click on the query, design, view. So it is the same thing, the same filters, except the project age, I don't need this one, so I can delete it. Oops. I don't want to do this, but I need this in here as well as a filter because I only refer to the forested area. However, I don't need these filters to show up in my query result, so I unselect them from the show row, and instead of group by, I would say where. Next, I need to drag in here the volume that I'm interested in. So I'm interested to know the live stand volume at 12.5 merge criteria. So I drag this in here and select sum. However, as you can see here, the live stand volume is already a multiplication between the area for each record and the actual volume per hectare. So to actually get standing volume, I am going to create an expression here, and this live stand volume would have to be multiplied by the shape area and divided by 10,000. So to do this, I need to use the square brackets to define the fields. So this is one field, live standing volume at 12.5. I'll multiply it with the shape area field. So again, square bracket, type in shape underscore area, close the square bracket, and divide it by 10,000. Hit enter. Again, this is an expression, so you can rename it, and you can call it live at 125 and hit enter. Now let's see the results of this query. So it shows me the area and the live volume. However, I only need the live volume at 125, so I can simply delete the area from here. Just leave this one and change the format to standard. Let's see the results of the query again. So it shows me the actual standing volume, which is about 105 million cubic meters. So let's create a query that determines the volume by site index, for example. So it's very similar to this query 10 that I did. So again, just copy and paste and rename it to, let's say, 11 volume forested by SI. Click OK. Right click on the new query I copied, design view. Let's drag here the site index field. So again, I don't know what it is. I just go by typing the letter S. And actually I need this site index before the live volume, so it looks nicer. Click view to see the query results. And here it is for each of the site index. I have a volume here. With this, I conclude this video. If you have any concerns, feel free to contact me using my email address.